All right, so this is a quick tutorial for the TI-84 Plus. I just want to go over some common types of calculations that you would see in an introductory chemistry course such as Chem 4, which is what this video is being made for. Now, a TI-84 Plus is probably a little bit overpowered for this class. It has lots and lots of capabilities that you would use in math classes all the way up to and through calculus. Nevertheless, I do see this calculator from time to time. So let's go ahead and make a demonstration with it. So one of the first things you'll learn how to do in Chem 4 is scientific notation. For example, 2.51 times 10 to the 5, which we can represent this in base notation as well as 251,000. But we need to know how to put it into the calculator using scientific notation. So the way that you do that is by this key called EE. Now, to access that EE key, you notice that it's not on the button itself, it's above the button and it's blue. So to access those blue functions, you have to hit the second key. So we're going to do 2.51, and then to get to that EE, we do second, and then hit that button. And now we do 5. And when you hit enter, you'll find that it's the same number. So what that means is EE means times 10 to the, right? So 2.51 EE, the EE button, and then 5. So that's how you would do scientific notation, by using that key. I also want to show what that would look like if you had a negative exponent, which, by the way, the exponent is up here. It's the number that's superscripted. So for example, let's not complicate things too much. Let's just say that you wanted to do 2.51 times 10 to the negative 5. So how would that be different? So to access a negative number, you've got two likely options. You see a negative sign here on the right side, and you see a negative sign here on the bottom. The one on the bottom is negative. The one on the right is minus, okay? So we're going to want to do negative. So we go 2.51 second E, and then negative 5. And when we hit enter, we get that number. So 2.51 times 10 to the negative 5, which, what would that be? That would be 0.0000251. All right, so that's scientific notation. Another thing that you will commonly do in class is take a number and multiply it by what's called a conversion factor. And a conversion factor can have numbers in the numerator, the denominator, or both. If it's a number in the numerator, that's pretty straightforward. I find that it's the denominator where people have some issues. So let's look at an example like that. So if we had 26 times 1 over 5.5, how would we process that? Well, the answer is 4.7. But what I want to point out is there are other ways to depict this, or to understand how this is going. First off, everything can be represented as a numerator and a denominator. Just as a reminder, numerator goes on top, denominator goes on bottom. Now you might say, well, what about 26? That doesn't seem to have a numerator or a denominator. In cases like that, it's automatically the numerator. And it actually does contain a denominator. That denominator is 1. But of course, if you divide anything by 1, it's just that thing again, right? So for that reason, we tend not to show a denominator if it's 1. If it's a numerator that's 1, we do have to show it typically. Now, in terms of calculating things, if you multiply by a denominator, that's the same thing as just dividing. So this expression up here could have been written a couple of other ways. It could have been written 26 divide 5.5, or it could have been written 26 over 5.5. These are all the same thing. All 3 ways of showing this are the same. So now let's put it in the calculator. That'd be 26 divide 5.5, enter, and we get 4.7. Now notice that I'm rounding. The calculator will spit out a whole bunch of digits. And in lecture, I teach you guys about significant figures and how to appropriately round and where the cutoff is. But that's not the focus of this video, so I'm just going to do it for you. So we would say 4.7 in this case. Okay. Now, what about if we have multiple things on top, multiple things in the bottom? So like 5 times 6 divided by 2 times 4. Now that turns out to equal 3.75. Now, there's a little bit of a conflict sometimes between what you think you're putting in and what the calculator thinks, right? Not that calculators think or anything like that. But for example, if I just said 5 times 6 divided by 2 times 4, and I hit the enter button, I get 60. That's not the right answer. So what went wrong? Well, let me write down what the calculator thought that you had put in, okay? So when you say 5 times 6 divided by 2 times 4, when you write that, here's what your calculator thinks. Your calculator thinks 5 times 6 divided by 2 times 4. So, whoops, something went wrong there, right? The 4 is supposed to stay in the denominator, but the calculator doesn't understand that. So we have to make the calculator to understand that the 4 should stay in the bottom. The way that we do that is by adding parentheses. I'm going to add parentheses to the 2 times 4, and that will force them to stay together. So now we'll do it again. 5 times 6 divide left parenthesis 2 times 4 right parenthesis. Now when we hit equals, we get 3.75 because the 2 times 4 is in the denominator as it should be. This is more of a problem for things in the denominator than the numerator. If it's supposed to be in the numerator, it tends to stay in the numerator. The denominator can be a little bit more tricky. Okay. One more sort of conversion factor type complicated one, and then we'll move on. I just wanted to do one where we had scientific notation in it, and it was in the denominator as well. So that's a series of calculations, and it ends up equaling 3.66 times 10 to the negative 23. So how would we put these calculations in? This combines a couple of the concepts that we already learned. So we do 37.3 divide 2.54. And for long calculations like this, here's my piece of advice. Just evaluate it every step of the way. In other words, before I put in the 3/2, I'm just going to hit enter, right? And then I'm going to say, we should multiply that by 3. So times 3, enter. And you see it says ANS. That's so the previous answer. It's just using the previous answer. And then we have a 2 here. So divide 2, enter. And then we have this long 6.02 times 10 to the 23. So that's divide 6.02 E23, enter. And we see that we get the same answer, rounded. So don't be afraid to hit that enter button several times as you go along. Me personally, I always do that. It also helps to see that the calculations are going good so far. Okay, what we haven't talked much about is addition and subtraction. Addition and subtraction is usually pretty straightforward, but once again, when we get into the denominator, things can get complicated. For example, let's say that we wanted to evaluate something like this, which equals 32. How do we do it? Well, we're gonna happen upon that same problem again, and I'm just gonna let it happen just so you guys can see. So 470 divide 39.5 minus 25.0, enter, and you get some ridiculous number, negative 13 or whatever. Once again, what happened is that the 25 ended up in the numerator, so we have to use some parentheses to get around that. So 470 divided by left parenthesis 39.5 minus 25.0 right parenthesis. And now we hit enter, and we get 32 as we were supposed to. Okay, I want to add one more complication to this, and then we're going to move on to something different. What if we have both multiplication and subtraction in the denominator? For starters, the answer would be 1.2. So you can keep that in mind. So in this case, we're going to have that same problem where it doesn't stay in the denominator. To get around that, I'm just going to wrap the whole denominator in another set of parentheses. So it'd be 470 divide left parenthesis 27.8 times left parenthesis 39.5 minus 25.0, and then we have right, so 2 right parentheses, enter. We get 1.16, which rounds up to 1.2. So it's okay. It's okay to overuse parentheses, right? Like to be overly cautious. That's okay. You're probably not going to get in trouble for doing that. All right, now we're going to shift forward in the semester. So later on in the semester, we're going to learn about acids and bases, and we're going to learn how to calculate pH. To calculate pH, we're going to have to use the log key. That's LOG. So for example, we'll take the logarithm of very small numbers usually. So for example, 8.2 times 10 to the negative 11, let's say. Now it turns out the answer to this is negative 10.09. So let's see how we use that log key with this calculator. So we got to look for it. It's right here, log. So some calculators you hit it first, other calculators you hit it last. So hit log, see what happens. Fine. It actually looks like what we already have. So let's type in the 8.2 times 10 to the negative 11, close parenthesis, enter. And there we go. We get a number, basically the same number, but I rounded. Typically though, when you do logarithms in this class, you'll do negative logarithms. So how would that change things? It's actually really straightforward. You just start out by hitting the negative key. So negative log 8.2 times 10 to the negative 11, enter. By the way, if I'm going fast, that's fine, right? This is a recorded video, so you can always slow down the video and you can repeat sections of the video to see exactly what I'm doing. One final thing to learn. In that same chapter, we will learn about using the 10 to the x key, converting logarithms back into concentrations, essentially, which will make sense when you get there. When you see something like this, when you see 10 to the blah, the automatic response for most people who saw the previous stuff is to go for that scientific notation key. But actually you don't use that here. Scientific notation only works if the exponent is a whole number, but that's not our situation. In our situation, the exponent is a decimal number. So because of that, you have to use a different key. And that key is right here. It's actually the log key, but you use the secondary function. It's a little bit blurry there, but you use 10 to the x, which is the secondary function of the log key. So let's go ahead and hit that second 10 to the x. And now you see 10 and then a box. So we type in negative 3.20, enter. And we get some sort of very small number, 6.31 times 10 to the negative 4. Actually 6.3 times 10 to the negative 4. So 6.3 times 10 to the negative 4, which I believe would be 0.00063. Okay, so if you can follow through on your calculator and get all the same numbers that I'm getting, and so you should be able to do any sort of calculation that we go over in this class. So that's it. Hopefully this is helpful. Good luck.